Hello friends, today we are going to cover a introductory section about track quality index, okay, in part 1, right? So in calculating track quality index we require basically SD means what? Standard deviation of different parameters like unevenness, alignment, okay. So we require standard deviation. So let us understand clearly about this, how to calculate this standard deviation. Okay, so if you see here, so this is the table in which see unevenness SD value, unevenness SD value on long chord. Okay, so you should understand clearly about the first parameter called SD. Next we also see here a term called peak. So this also has to be clearly understood. And then you have a term called nominal gauge. Nominal gauge. So this also has to be clearly understood. And then you have vertical and lateral acceleration. So I will give some idea about this term. Right? So these are the things we will discuss in today's class. Right? So overall what we understood. So while calculating this TQI, track quality index, right? So we should know how to calculate standard deviation of different parameters. We should also understand what is this peak value, what is this nominal gauge, okay, and these accelerations. So these four things we'll understand in today's class, right? So first one is what? Standard deviation. So standard deviation, so if you see this definition, helps to understand how track parameters are deviated about a mean value. So with respect to mean, how track parameters are deviated, that's what standard deviation means, right? More is the standard deviation, more deviated the track parameters with respect to mean value. Means if you get more SD value, it means more deviated. Lesser SD value will get what? Lesser deviated. So finally what we require? We require smaller SD values. So these are the things. Okay, we'll see clearly. See, first thing, this is mean. Mean also called as average. With respect to average, how the values are deviated. See, this is gone much higher from mean. So if you see this has gone much lower with respect to mean. So how much lower or how much higher? So this deviation is called standard deviation. So with respect to mean, how values are deviated, that we'll see, that we'll understand using standard deviation. Suppose see here you got SD is equal to 4, here SD is equal to 2. Now tell me which one is better? SD is equal to 2 is better because these values are deviated less with respect to mean compared to this value. Okay, so if you see here, see this is more deviated and this is less deviated, so we require this thing compared to this one, right? So overall what we understood, more is the deviation, right? More is the standard deviation, more deviated the track parameters are, right? Lesser deviation means okay, lesser standard deviation, lesser deviation of track parameters. So we require SD value small for our data, right? So you got some idea about what is SD, standard deviation. Now let us understand how to calculate SD value, right? So there is a formula to calculate SD called, so if you see here, right, so if you see here, okay, so SD is equal to x1 xi minus x average whole square by n. So just remember this formula to calculate deviation. So I will make you understand using an example. So we have, so over short chord we have, let us say you have un1, What is un1 and un2? un1 means it is over short chord, un2 means it is over long chord. So I have taken some data of this un1. So if you see this table, see, so these are the values of unevenness over the short chord 10, 15, 20, right? Now for this data I was supposed to calculate average, also called as mean, and also standard deviation. Okay, I'm supposed to calculate standard deviation. So how to calculate? Let us see here. So you have this data of unevenness and these are 7 in number, right? So first x average I am calculating this term. So x average is equal to what? 10 plus 15 plus 20 plus, so it means simply average of this data. Okay, it is simply average of this data. Okay, right, that I have calculated and I got around 14.285. Now next, once I got x average, now I will calculate this. So SD is what? Xi minus x average whole square sum. So first value 10 minus average, this is average value whole square, plus second value here, second value minus average value whole square, plus third value minus average value whole square, plus like that for all values I have calculated. Similarly, so up to here 14 minus 14.285 whole square. Now this entire value, these entire differences I have added and I got around 105.4. So this numerator, and n is what? How many values are there? So here you have 7 values, so whole square root I have to take. Now I got around 3.88, right? I hope this SD calculation is clear. So like this you can calculate SD for unevenness data, okay, alignment data. So you can easily calculate unevenness. So here you are given only 7 data points. Suppose you have 800 data points, 1000 data points, you can simply calculate this value of SD, right? Now, so at this point you are clear with standard deviation. So what is standard deviation? How to calculate standard deviation? Now let us understand peak value. What is peak? Suppose you have, peak means highest value. Suppose you have 12, 10, 3, 15. What is peak among this? So 15 is the highest. So this is peak. This is highest, right? Nominal gauge. So gauge means, you know, right, 1676 mm. So this is called nominal gauge. Mean gauge means average gauge, also called as average gauge, right? Next, accelerometers and gyroscopes. So we'll see this through this picture. So if you see here, now let us understand this table. Say you have here vertical and lateral acceleration. So to measure them, so if you have a track like this, the train can move like this or like this, okay, or in this direction. Okay, so vertical or horizontal linear acceleration, okay, this was measured by accelerometers. Okay, vertical acceleration or horizontal, so this direction, so this like this, okay, this or vertical acceleration was measured by accelerometers. Next, you have gyroscopes. So this will measure angular acceleration. So see how this body will rotate like this, okay, so measure angular velocity. This is how quickly the object is turning like this. So you have a track like this, so body may turn like this or body may turn like this, okay, so how fast this will turn, that was measured by gyroscopes, right? So these are the things covered today. So if you see, we know how to calculate this SD value of unevenness. So if I give unevenness data, you can calculate SD value, and formula is what? Square root of xi minus x bar whole square by n. Square root is for whole, right? So that's how we will calculate SD. Peak value, you know, highest value. So these also you know. So vertical and lateral acceleration, you got some idea. Mean gauge means average gauge, nominal gauge means 1676 mm. So okay, so these are the things covered, friends. I hope all the concepts was clear to you. Thank you.